Hello and welcome to my video. Today we are going to calculate the area enclosed by the curve given by this equation. So in order to calculate the area, first we have to sketch the graph. And doing so requires two properties of the shapes on the coordinate plane. So the first one is the equation of the circle. This equation, x minus a square plus y minus b square equals r square, is a circle with center a, b and radius r. So basically we have an equation of a circle here, but also here we have absolute values combined. This leads to the second property that I'm going to talk about, the symmetry of the shape. So this is the example of an implicit function. That is, if we write the equation for the curve as this, and if we let this part as fx, y, then the equation of the curve can be written as fx, y equals 0, hence the name implicit function. Here, notice that the equation doesn't change by substituting minus x for x, or minus y for y, or both. We can also express them like this. F minus x, y, which means we replace x with minus x, is equal to the original function fx, y. And similarly, if we use minus y instead, the function is unchanged. And we can say the same thing for using both minus x and minus y. Now, if point x, y is on the curve, then it satisfies this equation. Then the first expression means that point minus x, y also satisfies the same equation of the curve. So for every point x, y that is on the curve, point minus x, y is also on the curve. And since point x, y and minus x, y are symmetric with respect to y-axis, it means that the entire curve is symmetric with respect to y-axis. Similarly, the second property means that point x, minus y is also on the curve, which means that the curve is symmetric with respect to x-axis. And the third property means that point minus x and minus y is on the curve, so the curve is symmetric with respect to origin, 0, 0. So we have the following conclusion. The curve is symmetric with respect to x-axis, y-axis, and the origin. Therefore, we only need to investigate the curve on quadrant 1, which is x is positive and y is positive, and then perform symmetric operations with respect to y-axis, x-axis, and the origin to obtain the whole curve. So, on the first quadrant, the equation is x minus 2 square plus y minus 2 square equals 16, which is 4 square. This is the circle with center 2, 2 and radius 4. So what we have to do here is to draw this circle on the first quadrant, and it looks like this. 2, 2 is center and 4 is radius, and we perform a symmetric operation with respect to x-axis, y-axis, and the origin. Then we obtain the curve like this. Or we can simplify the equations of the curve for all 4 quadrants by dividing into following 4 cases. So in the first case, we have these equations. This is the circle with center 2, 2 and radius 4. And for the second case, we have this equation. So the center of the circle is minus 2, 2 on the second quadrant. And for the case 3, which is the case for the third quadrant, the center of the circle is minus 2, minus 2. And in the fourth quadrant, the center is 2, minus 2. And if we draw all of them, we can obtain the same curve. Right? So this is the curve. And now let's calculate the area inside the curve. Alright, in order to calculate the area, we must find some lengths and angles. First, notice that this length here is 2, and this length here is also 2. So here we have 1:2 ratio, which means that this triangle is 90 degrees, 60 degree, and 30 degrees triangle. And we can find out that this length here is 2 times square root of 3. So the x-coordinate of this intercept is 2 times 1 plus square root of 3. And we have right angle here, and this angle is also 60 degrees. So for this remaining angle, we can find that it is 150 degrees. Now notice that area A enclosed by the curve consists of 4 sectors with radius 4 and angle 150 degrees. And then we have some triangles, and actually, let's pick this triangle. And there are total 8 of those triangles. The base length of the triangle is 2 times 1 plus square root of 3, and height is 2. So first, the 4 sectors. So we have 4 times pi times radius square, so 4 square. And this is the area of a circle with radius 4, and the entire circle has a center angle 360 degrees. But here we only have 150 degrees. So we multiply this. And for the triangle, we use the famous 1/2 base length times height formula. So here this reduces to 5/12. And if we cancel with this 4, we have 3 here. And here we simply cancel out these 2. So we have 18/3 pi plus 16, 1 plus square root of 3. And this is the entire area enclosed by the curve. And that was all for this video. Thank you for watching, and please like and subscribe for more math contents, and I will see you in another video.